Hi, today we are going to see about zero forcing algorithm and LMS algorithm. The algorithms for adaptive equalization. Practical considerations for choice of an equalizer structure and its algorithm. The cost of the computing platform, especially when used in user equipments, the power budget in portable radio applications, battery drain at the subscriber unit is a paramount consideration. The radio propagation characteristics. The speed of the mobile unit determines the channel fading rate. The three basic equalizations are linear equalization. Its performance is not very good when the frequency response of the frequency selective channel contains deep fades. Zero forcing algorithm aims to eliminate the inter-symbol interference at decision time instance. The least mean square algorithm and recursive least mean square algorithms offers faster convergence but is computationally maximum complex than LMS. Zero forcing algorithm. To force the sample of the combined channel and equalizer impulse response to zero at all but one of sample points in the tapped delay line filter. The disadvantage of zero forcing algorithm is it may excessively amplify noise at frequencies where the folded channel spectrum has attenuation. Linear equalization. Zero forcing equalization. Zero inter-symbol interference at the receiver output. The figure shows the zero forcing equalization technique. In this, the transmitted impulse sequence is given to the communication channel, which contains FIR filter, and then to the equalizer, which contains two m plus 1 coefficient FIR filters, and the equalizer gives the input to decision circuit. The channel impulse response and equalizer impulse response equations is given as h of k and c of k. Coefficients of equivalent FIR filter f of k is given as summation of n equal to minus m to m cm h k minus m. Overall filter response of the zero forcing equalizer is given in these equations. Activity. Least mean square algorithm. To minimize the mean square error between the desired equalizer output and the actual equalizer output, it minimize must be solved iteratively. It is the simplest algorithm. It requires only 2n plus I operations per iteration. The LMS equalizer maximizes the signal to distortion ratio at its output within the constraints of the equalizer. The disadvantage of least mean square error algorithm is low convergence rate because of the only one parameter alpha, especially when the eigenvalues of the input covariance matrix have a very small number. To prevent the adaptation from becoming unstable, the value is chosen as from the given equation. The step size can be controlled in order to avoid instability in the equalizer. For convergence towards minimum mean square error, these iteration index step size iterations are used, and these are given in these equations. After some calculation, the recursion equations are obtained in the form as shown. Conventional linear equalizer of LMS type is given in this block diagram. Joint optimization of coefficients and phase is given in this block diagram. Effects of iteration step size. For smaller value, the acquisition is slow and poor tracking performance. For larger value, the stability is poor, large variation around optimum value. Assessment questions. The decision feedback equalizer has a linear transfer filter, which is feed forward section or feedback section, or both of the mentioned or none of the mentioned. Choice of equalizer structure and its algorithm is not dependent on cost of computing platform or power budget or radio propagation characteristics or statistical distribution of transmitted power. The answer for the first one is feed forward section and the second one is statistical distribution of transmitted power. Thank you.